Hello friends, welcome to Maths Nerd.
Today we will learn about time and work.
There are a few rules which we need to discuss before solving examples based on time and work. So, these rules, for these rules, let m equals number of men, they can also be machines, t equals the time, and w equals the work. So, m into t is proportional to work in the same work where the speed of men is same in each condition. So when we want to keep the work constant and increase the men, so we need to decrease the time. And when we want to keep the work constant and decrease the men, then we will need more time. The third law is that if either of these increases, for example, if men increases and time remains constant, then the work will also increase. Or if the time, or for suppose if either of these decreases and the other remains constant, so the work will also decrease. And this would be true even if time decreased or increased and the men remain constant. Now let's see one more thing. If the work in two conditions is same, then the product of men into time in the first condition is equal to the product of men into time in the second condition, if the work is constant. Only if the work is constant in both conditions. Now let's see this in action.
Let's see an example.
So our question is, if 16 men do a piece of work in 15 days, how many days will 24 men require to do the same work? So here we are given two conditions. In the first condition, the number of men are 16 and the time taken is 15 days, while in the second one, the number of men are 24 and we have to find the time. So here the work remains same, and so we can apply the law here that m1 into t1 equals m2 into t2. So here the number of men are 16, the time is 15 equals the number of men here are 24, and let's keep the time as t2. So to find t2, we'll write t2 equals 16 into 15 divided by 24, as when we'll divide the right hand side by 24, we'll be left with only t2. So we can cancel it as 3. Well, this is 2, 8 2s and 8 3s, and this is 5. This is 3 5s and 3 1s. So we have got 10, but since the unit of time in the first condition was days, so here also it will remain as 10 days.
Another example coming up.
Here the question is a bit hard. If 3 machines working 2 hours each day work for 4 days to complete a work, then how many hours each day will 6 machines work in 6 days to complete the work? So here we first need to find the total time the machines worked in the first condition. So if it is 2 hours each day for 4 days, so this means 2 into 4 equals 8 hours. And this is the key for finding the hours worked if there are hours each day in 2 days. Similarly, in the second case, let's take the hours each day to be x, so it will be 6x hours. Now since the work in both conditions is same, let's write m into t. So here we have got 3 as m and the time is 8 is equal to this. We have got 6 as m into 6x. So 24 equals 36x, and to find the value of x we will divide 24 by 36, so that is equal to 12 2s and 12 3s, so 2 upon 3 of r, and we can even simplify this as 40 minutes. So 6 machines working 40 minutes each day can complete the same work in 6 days.
Feel free to ask your doubts in the comments.
Thank you for watching this video. Please like and share this video and don't forget to subscribe my channel for more videos.